Okay, so today's lecture, sorry, things are a day late. Yesterday, a bunch of people had some questions they wanted to meet in the Java class. So that kind of put me behind. The videos like coming out. Still a couple more people I'm going to try to Zoom with today in order to catch everybody up. So that's kind of where we're at. In general, the videos will come out Monday. Sometimes it'll be Tuesday if things get crazy, but that's the general idea. And somebody had a request to put out the problem set even if the video is late, and I certainly can do that and need to do that. The problem set will be out there as soon as this video is over. So this week, the schedule says we're going to cover chapter 6 and 7. I think people are still having some trouble, hence all the meetings yesterday and some today. So I think that it makes sense to this week to let's just do 6 this week. If you've read 7, you're ahead of the game, life's good. Okay, but if not, let's just focus on 6 this week to get everybody caught up. Okay. And one of the questions that I've had from more than one person is about when we use private, when we use the this, those kinds of things, okay? So I think it's a problem that I didn't spend enough time on, so let's talk about it. So in Java, every file we create is a class, okay? It's just how it's an object-oriented all the way language. Everything is a class, okay? So, but among that, there are two types of things. We create a class we're going to use again. So it's not an application. So the book in the homework will say create an application. They mean create a program that has a main function, has the public static void main, and that you can run that, okay? Other things back from chapter 3 said create an employee class, okay? So there's a class file that's a class, and there's a class file that's an application. That's where it gets confusing, okay? So in Eclipse, when you go to create something, it'll ask you, there's an option. Do you want to include the public static void main? Okay. If you're writing what the homework problem says is an application, you want that public static void main. Okay. And if you have the public static void main, you're not going to be doing the public and private. You're not going to be doing the this. Okay. You're not going to be doing the accessors, the mutators, none of that. Okay. But if the homework problem or the test problem or whatever ask you to create a class called something, a class student, a class vehicle, a class polygon, okay? Then you have to worry about defining for that class. That class is now a class, okay, not a program, okay? So, or not an application. So that class would have to have its member data, its member functions, the public, the private, accessors, mutators, all that stuff, okay? So that's, so far, the only time we've done that is in chapter 3 when we're creating classes. Okay, we still create a new class in Excel or in Eclipse, but it's that whether or not it has the main function that makes a difference. If there's a main function, there's no accessors, mutators, public, and no use of this. If it doesn't have a main function, then there is. Okay, I hope that's clearer. Okay, and I'll try to in the homework at the end of this chapter, I'll try to give you a heads up on how that's going to work. Okay. So chapter 6 is going to go further into the idea of methods or functions, okay? So these are going to be bits of code that we can reuse, we can send things to, and get stuff back out of, okay? So we're going to kind of talk about those different things, okay? Again, my assumption is that you have already read the chapter before you watch this video. If not, stop the video, go read the chapter, just read chapter 6 for this week now. We've changed that around. I think it'll make a lot more sense. Okay, so I'm hitting the highlights. I'm not hitting every single thing, okay? So it starts off with just some general information about how Java gets laid out, but the first real material that we care about is gonna be in section 6.3 on static methods, static fields, okay? So the word static in programming has a different meaning than it does in the world. In programming, static means that it relates to the class and not an instance of the class, okay? And we've seen that when we use a math function, like the math, we did the math.py, okay? Math is a class out there somewhere, a class definition, okay? When we say math.py, we're not dealing with an instance of the class. We don't have to say my math is equal to new math, okay? We're just gonna do those variables that are directly from the class itself, okay? And that's where the static comes in, okay? And when we do our application program and do the public static void main, that's a static because it's not creating a class in the traditional sense, and it's not going to create any instances of itself, okay? So when you write a program that calculates the area of a circle or whatever. Okay, you're not creating a class to hold circles. Okay, so it doesn't have anything to relate to that. You're not going to create an instance of your class. Okay, so that's really the difference there. So you can have functions that require or methods that require an instance name, which we see a lot, the ones that we create. Like if we're doing the employee class, we call employee one, we could say employee one dot get salary. Okay, that's not a static function, that's a regular function. But if we were to have a function that relates to all the employees, it would just be employee dot whatever. That would have to be a static function. Okay, so hopefully that is going to make some sense. Okay, also a table in the book on page 216 on some of the static functions of the math library. Okay, some of the class methods there. Okay, and things such as absolute value, ceiling. There's all the trigonometric functions. There's logs. There's a power function that will raise something to another power, square root, those kinds of things. Okay, and you can use those in your program, again, prepending it with math dot. Okay, and then the static variables that we have for the math library, we have a pi and we have e. Okay, which we can use those. Okay, the next section talks about methods that have multiple parameters. Okay, and it's pretty common to see that. That if you have a function, you can have just one thing that it takes, or you can have multiple things that it takes. Okay, so we can look at an example of this. Let me share the screen over here, the clips. Okay, so let me find a way I can type and look and see and everything simultaneously. I'm still visiting my parents, so I'm in a weird environment for me. Okay, and in this case, this is just on my test one. Yeah, it's just a test program. So I don't care about any of this. Let me just get rid of all that stuff. Okay, and I'm going to write a function here. Okay, this one's going to be, this function is going to be called maximum. Okay, it's going to be a public function. So we're going to do a public. Okay. And they actually define this. Actually, it's interesting the way they're doing this one. I think I killed something didn't need to kill. So they've got another program that's doing some things. Okay, and then they're going to create a maximum function that's outside of this class. Okay, so that's that class. So down here, they're going to have this public static. So again, it relates to the class, not to an instance of the class. Okay, so public static to double called maximum. Okay. And it's going to take a double x, a double y, and a double z. Okay. And then on this function, okay, we're going to have, there. Oh, it doesn't have too many of those apparently. That's it. Okay. It's not happier. What's one more there, maybe? Okay. Who knows what it's unhappy about? I'm doing just an example, so we'll see. But the idea here is that we have these three variables that we're sending. Okay. So if I were going to call this from up here, that's really the issue here. I would say something like double result is equal to maximum. And then N1, N2, N3. Okay, these are not numbers I've defined yet. I would have to define those and have values, but I'm not. But when I call that down here, I can just call the maximum because it's a static. Okay, and it's going to have those three values. And the thing to note here is that whatever the value of N1 is going to become X in this function. Whatever the N2 is going to become Y, and the N3 becomes Z. Those line up exactly with how they're done. Okay. And then when you're done with that, you can just return the value directly. Okay. So public means that you can get to it. Static means that you don't have to attach it to an object. Okay. So that's an example of a function that has the multiple things that you can have. Okay. And again, if I would call it with one more, this is going to give an error, right? Because it expects there to be 3 doubles coming in, okay? And I'm sending 4. Wouldn't like that. Same way if I just sent 2, it would also create an error, okay? Now we can overload the function. We can have more than one version of the function or the method that takes different parameter lists, and that's okay. Okay. Okay, so a couple things here. This is in section 6.5, some notes on the methods. There are 3 ways to return control when your statement to the statement that called the method. Okay, so you can either just hit the end of the right end bracket, the right curly bracket or brace is reached in the method. Okay, if there's a void function. Okay, so in this case here, we have our public static double down here. Okay, so this double refers to the return type. So at some point, I'm going to have to return something. Okay, it wouldn't be an X, let's say M or whatever. Okay, that will end your function. If this were a void, okay, so if this for some reason were a void function, then just when I get to the last bracket down here, there wouldn't be a return statement if there's a void. I'm not returning anything. Okay, so that's the second way. Okay, and then it can also be when the method returns a result with a statement which has an expression to be evaluated. So I could do something like a return. I wouldn't in this case, but you could. Okay, so those are the 3 ways to return from a function call. Okay, and the way this would work, the program flow would come through here. It hit the main first. It would hit this call. It would stop where it's at. It would come down here and execute this. When it hits the return, it would go back to where it was, now having a value for all of that. Okay. So one thing to keep in mind here is that static members can access only the class's other static members directly. Okay, so the static members can access each other with no issue, but if you're trying to access a non-static, okay, then it's going to relate to a particular instance of the class, then you would have to use the normal accessors or mutators to either get or change those. Okay, so that's a pretty standard way of dealing with things. Okay, 6.6 talks about the method call stack, the activation records, and we don't need a whole lot of detail on that right now. That just gives you kind of an idea that when you make a call to a method, it's possible it could call another method along the way, and it's just going to keep track of that kind of in order of what's happening. So if you're in the main program and it has control, then it's going to call the maximum function, which could call another function, and then when the furthest one out ends, it goes back to the one it was at before. Okay, so it can build up a stack of these that then comes back down. Okay, so and it explains that in a little bit more detail. If you have questions about that, you can certainly ask. But that doesn't come up directly in our programming typically. Okay, note that you can push things too far and have too many functions open at the same time, in which case you can have a stack overflow. Stack overflows when you run out of memory. Okay, we're probably not likely to get there. Okay. Another thing that you can do in some cases, if in the program that I have on the screen here, the maximum, it's wanting a double. Okay, if I would send it an int is not a double, should give us an error, but it doesn't, because it does what's called argument promotion. Okay, so there are some times when if we say we want a double, we send it an int, it's like, okay, if the int is 5, let's call it 5.0. Okay, and it can do that for you automatically. Okay, which can be useful. Okay, there's a table on page 224 that goes through different types and what they can be promoted to. Okay, which can be useful. Okay, 6.8 goes through the list of some of the predefined packages that Java has. It's a bunch. It's a bunch more since this book was put out. So that just gives you kind of a roadmap. Again, you can look at that to get an idea of things. We'll use them as we come along, but there's nothing really to memorize there. Okay. The next step is interesting somewhat, and it's this idea it's the case study in 6.9 on secure random number generation. Okay, and random number generation turns out to be a historical and a very interesting problem in computer science. Okay, and it's this idea that a lot of security applications, in fact, most if not all, require this ability to generate truly random numbers. Okay, it turns out computers cannot generate truly random numbers, and there's a whole theoretical discussion about why that's true. So we usually get what we call pseudo-random numbers, and they're random enough for games and other applications. Okay, so the case study talks about there's a function we can do called random that's in the Java security package. Okay, because again, they're used so much in random or in cryptography and things like that. Okay, so for this one, and you can go through this this example, it's worthwhile doing. We're going to create a secure random object by saying secure random numbers equal to new secure random. We've done that new keyword before. It's going to allocate memory for an object. Okay, we can then do the random value is going to be the random numbers dot next int. Okay, so the next int is going to look like our input function we create from the scanner. So it's going to be similar. Okay, and in fact, let me show you this code. That probably makes the most sense. So let me do another share again. I shouldn't have gone away from that. Okay, so again, I'm just doing some code snippets here. This is not going to work. It's not part of anything else. But if I have to first I have to import the java.security. Okay, so I assume that I've done that. Then I can create a secure random is the class. I'm going to call it numbers is equal to new secure random. Okay. Again, I'm getting errors because I haven't loaded in everything correctly, but that's the idea. Okay, once you have that, then I could say something like int find the home keys. Random value is equal to that random number that I just created, numbers dot get int. The get int is going to return an integer. Okay. If I wanted to turn that instead to a certain number, okay, where it has a certain range, if I do a get int 6, it's going to give me an integer between 0 and 5. Okay, so if I wanted to do a dice, I could do something like int, I've got the variable face for some reason. I could say it's equal to 1 plus random numbers. Okay. And what that's going to do for you, it's going to do that 0 to 6, it's going to add a 1 to it. Okay. So, and it turns out that we use that a lot in games. Okay. We're going to get an example program on rolling a dice on page 229, and it's going to roll a 6-sided die 60 million times. Okay. And it's certainly worth going through that, how we're going to go through and calculate that and roll the dice that many times. Again, we're going to import the java.security.secure random. We're going to create a random numbers. We're then going to go through a loop, and in our loop that goes up to 60 million, we're going to roll the dice, and then we're going to track via a switch statement. So it's another good example of switch statements on how that's going to work. Okay. So it's probably, let me see what's left in this chapter. I think it's probably worthwhile. Yeah, we can probably type that one in real quick, at least the parts of it that matter. Okay, so let me go ahead and create here a new class. Okay, and this is called roll die. Okay, and this one it's an application. So I'm going to put this public static void main. Okay, so I have this up here. Okay, so again, it's going to start with this import java.security .secure So that's our secure random. That's our roll die function and our public static void main. We're going to start by declaring a new static, or a new secure random. Okay, so we're going to have secure random. Let's call it Rn for random numbers is equal to new. Okay. In this case, we're going to do an int frequency 1 equal to 0. We're going to have frequency 1 through 6, so we can count the numbers here. That's a 1, 2, 3, 4, 5, 6. 1, we have our 2, we have our 3, we have our 4, 5, we have our 6. This is going to be our accumulators. We're going to count those each time. Okay. We're going to start our for loop here. So we're going to say for int roll equals 1. That's where we start. Semicolon. As long as roll less than or equal to 60 million. And something I haven't seen anyone do. It's interesting. They do an underscore. You can't do a comma, I know, but let's see if that really works. It's very intriguing to me. Everybody programs differently. Roll plus plus. Okay. Seems happy enough. Okay, so again, apparently you can do the underscore if you want to be able to visually see where the commas would be, which is fine. Okay, so each time through on this loop, we're going to have to get our new value 1 plus our Rn we created dot next int. Okay, so again, that's going to give us, and we're going to put a 6 here. This is going to give us the 0. This part gives us the 0 to 5. That gives us the 1 through 6 by adding the 1 to it. Okay, and then for each of these inside of here, we're going to go with our switch on face. Okay, and then we'll have all the different cases. I won't do them all, but for case 1, for example, we're just going to do plus plus on the frequency 1. Okay, and then a break. And again, I can copy that. For case 2, case 3, case 4, case 5, case 6. Okay, now I just have to go through and change those numbers. I can do real fast. Case 1, case 2, 2 there, 3, 3, 4, 4, 5, 6, 6 each time. Okay. And then the other thing that people are having trouble with, I think, is the brackets. So it's not a bad idea to go ahead and have some training wheels here. So this bracket here starts the switch. So when we come down to here, we know that this bracket end the switch. Just put a comment there. Okay. So this one, that closing one, then it's going to do what's above that, which is this one. Okay, so that's going to end at the 4. Somebody said they just put in brackets until it quits complaining. This will give us a better idea. Okay, this one then is going to end. If you can see them all, it'll light up what it's doing. Okay, this is going to end the class or the main, and that's going to end the class. Okay, so we can then come down here and say main, and finally, which can be helpful. Okay, and then when we've done, when we're out of all of that, okay, when we're out of the switch and the 4, then we can do our prints. Then we can do a system.out.print line. If you want, you can just say something like let's see, let's do a printf instead. Printf, say something like there were %d rolled. Okay. %f then has to be, that's going to be the F1. Okay, print that out. And if you want to keep your spacing nicer, you can go to the beginning of your line and hit tab, and it should take it wherever it needs to be. Okay. And this should work theoretically. Let's run it and see what we get. There's an error. What doesn't it like? Let's see what it doesn't like. I know those aren't being used. You know, that really shouldn't be keeping that from running. I wonder what that's, if that's really the problem. Those are being used. So what? Yeah, because they're used down here. Yeah, I'm not sure. I'm doing something odd apparently, which is strange. So it's not working. I'm not sure why, but that should be the basic idea how that works. Okay, that we're going through and calculating every time through what the roll of the dice is. Okay. So there's another interesting thing here in section 610 on a case study on a game of chance, and it's going to introduce the idea of enumeration with the craps game. This is something else you should definitely type in. It's fun to create your own game. Okay, and the new thing there, we won't do the whole program, although it is worth doing. It's an enumeration which allows you to control what people can type in. Okay, you can give certain values. Okay, so for that, outside of my main, so inside of my class, so in here, I could say the following. Okay, I can say private enum for enumeration. Final, no, not final. It's not a final. Final means it's a constant, which is not. Let's do status. Okay, so let's say I want the status to be only certain values. Okay. So are those, let me see, those are curly brackets. Those are curly brackets. I suspected they were. Okay, so when I say private enumeration status, okay, continue one lost. Okay, it means that these are the only values that status can contain. If you say status is equal to continue, you're fine. If you say status equal to continue with a small c or small letters, then it's not fine. Okay, so that allows it to constrain to that particular value. Okay, but that program's interesting to go through. I would definitely look at that. Gives you an idea, and it explains what it's doing for that example. It's a good example. Okay, so let's see what else we've got in this chapter. It talks about the scope of declarations. Okay, so we have declarations of classes, methods, variables, parameters, all that stuff. Okay, so here are the scope rules we're going to use in this language. The scope of the parameter declaration is the body of the method in which the declaration appears. Okay, so if you define something inside of this main function, then it has scope or it has value in there. If you're in a different function, it's not going to have any value. Okay, so that's kind of the idea there. Okay, same thing with a local variable. From the point that you declare it to the end of that block, it has value. So this int f4 here has no value until line 11. It's going to keep its value as long as we're inside of the main. So all the way down to here, it has value. So right here, it still has value. Right here, it does not have value. Okay. Anything that appears in the for statement. So when we declare a variable here in our for loop, int roll only exists between here and the end for. It's only in that scope. Okay. So you're going to run into some issues with that sometimes. And there's an example on page 236, figure 6.9, that goes through that and gives you a demonstration of how that works. Okay. I'd mentioned before that you can do method overloading. Okay, a method overload again, and let's just do another dumb example. What have I got here? I don't know what I've got here. I don't care about that. Okay, so if you define one function, okay, so the function could be outside of our main, but inside of our class. Okay, so we have another function. We do a public static int square. It's going to take an integer called int value. Okay, we're then going to define that function. Okay. So it takes an int, one int, it's going to return the square of that function. Okay, so that's just going to do nothing. I'm going to type that in, it's pretty simple. I'm going to return int value times int value. Okay, that works for integers. Okay, if I want to overload that to work for another variable type, give it the same name, but it has to be different in its signature. A function signature is the number and type of parameters that it has. Again, I'm hitting the tab to get this lined up. Okay, so instead we can have here a double. And note what it says here. It's like, wait, you can't do that. It's giving me an error because I've declared it twice. Okay, but in this case, I'm going to move it to a double. Where it's going to take a double called double value. Okay, that will have double value. It's going to return double value times double value. And now we're okay. We've got rid of our errors. Okay, so this function square has two versions now. One version that takes one int, one version that takes one double. Okay, and it's going the computer is going to be able to figure out which ones to run because it can pick the one that matches exactly. Okay, let's see what else we've got here. Okay, that looks like it's pretty straightforward. We're going to skip for now any of the optional GUI stuff. I think it's just we've got enough going on. So there's some GUI stuff there if you want to look at that you can. Okay, but if not, that should be good. Okay. So the last thing I wanted to mention this video here is the homework. We'll talk about what's there. And again, I'm going to post it on Moodle here in a minute. So this is going to be on the exercises at the end of chapter 6. Okay, we're going to do, first one is problems, exercise 6.8 on parking charges. Okay, again, if you read through this, it's going to ask to write an application. Okay, so this is not going to have any private stuff. It's not going to have any this. Okay, as far as that goes. So you can write an application. I'm going to create some methods there. Okay, and the next one is 6.15 on hypotenuse calculations. Again, you're going to create a hypotenuse function. And then 6.20 on creating a function that does the area of a circle, or a method that does the area of a circle. And another one that does 6.25, you're going to create a method that does the prime numbers, see if the number's prime or not. Okay, and you'll write some test programs for that. Okay, so this, we're going to create those functions. Okay, and our functions, just so we're clear, we're doing, again, something kind of different than we were before. The functions are not defined in the int main typically, they're in their own section, but they're all in the same overall class file. They're able to call those, okay? And again, your best bet after you've read the chapter, go through those case studies and type those in. Don't cut and paste to find it online. Go through and type them in and kind of try to understand as you're going along what each step is doing, okay? I think that's the best way for it to happen, okay? Now, if you see this today is Tuesday. It's Tuesday afternoon, a little afternoon. I'm going to try to get back to those that are still needing help. and we'll try to figure out a way on, moving forward to have some different help sessions. And this week we'll meet on Friday at 7 to discuss whatever questions you may have about things. Okay, I'll make a video of that as well. Okay, so that's all I've got for now. So if you have any questions, as always, text or email, and we will figure it out.